Why I'm doing so? Because either a network administrator, server administrator, the full form of IP term is Internet Protocol. It is a logical address assigned to every device in the network to identify the particular device in a network. Without having a proper IP, no device can communicate over the network. There are two types of addressing in the networking. One is logical address that I'm showing you, and one is the physical address. Okay. So IP is a logical address, means can be changed, but every device in the networking have a physical address also. That is the MAC address. So I will not go in depth for the MAC. Right now we have to discuss about the logical address that can be changed with time to time. But without having a proper logical address, it's not possible to communicate over the network. So this is the structure like this. You need to configure on each device, like I show you my computer also. Network and sharing center, adapter setting here. I'm showing again properties. If you and you check IP version 4, here you can see we need to configure it. One option, obtain the IP address automatically, that is via DHCP server you need to configure, but manually if you need to configure, you have to configure IP address, subnet mask, default gateway and DNS, so that your device will be able to communicate over the network or internet. Without having these settings, device cannot communicate over the internet. So just only for your reference that I shows you. Okay. So this is the IP address. So without having this IP address as well as subnet mask as well as gateway, your device will not be able to communicate over the internet. Okay, so you should have all these things. So we have to focus on these two things right now, IP address and subnet. I will discuss with you about the IP address and subnet mask in very detail in upcoming slides. So actual definition you can say is a 32-bit address. It is a 32-bit address, logical address, divided into 4 octets separated by a decimal. Why it's bits here? Logical address or IP address is designed in binary number system, not in the decimal number system. I was showing you previously here this is a decimal number system, but actually IP is designed in binary number system. Hope you are familiar with bits and bytes term. So 32 bit divided into 4 octet separated by a decimal. Now what is this octet word? I don't want to leave a single word that make you confused. Octet is basically a collection of 8 bits. In normal, it is called byte. Collection of 8 bits is 1 byte. But here, in case of IP, it is called 1 octet. Collection of 8 bit called 1 octet. Collection of 8 bit called 1 octet. So let's check the actual structure of IP. This is the actual structure of IP. What I say is 8 bit separated by decimal, again 8 bit, then again separated by decimal, then again 8 bit separated by decimal, and then again 8. So 8 plus 8 plus 8 plus 8, 32 bit. Same for the subnet mask. 32 bit, 8 bit separated by decimal, 8 bit separated by decimal, 8 bit separated by decimal. So collection of 32 bit. Now, before proceeding, you must be familiar how we can convert decimal to binary and binary to decimal number system. If you don't have the thorough knowledge of this conversion, again become difficult for you when we go for the advanced topic of subnetting and VLSM or CIDR. So I'm not take much time because I expect that you all know, but still for easiness, I'm just taking a few examples here. Like I have taken decimal number system 92 and I want its binary number. So what I do? I divide by 2. Divided by 2. Then 96 remainder 0. 48 remainder 0. 24 remainder 0 divided by 2. 12 remainder 0 divided by 2 6 divided by 2 3, again 3 divided by 2 1 and remainder 1. So now what I will like this way from down upside. So 192, the decimal number system equivalent to this binary number system. Clear? So very easy, nothing complicated, just practice some few things, you will really clear to you. If I go the reversal process of this, look here. This was the 192 binary. So what we do here, writing is little poor. This is a 0 position, first position, second position, third position, fourth position, fifth position, sixth position, and seventh position. So 2 raised to power 0, 1, 2 raised to power 1, 2, 2 raised to power 2, 4, 2 raised to power 3, 8, 2 raised to power 4, 16, 2 raised to power 5, 32, 2 raised to power 64, and 2 raised to power 128. Okay, so 128 multiply by 1, it becomes 128. 64 divided by 1 becomes 64. Remain all are zeros, it becomes 0. So when we add, we get 192 back. So in this way, we can do decimal to binary and binary to decimal conversion. Okay, same process here. 160 is the decimal number system, keep dividing by 2. what happened? Yeah. Look here. 10101000. It will be the equivalent to 68. 10101000. Start from this side to this side. Same is the reversal process. 10101000 2 raised to power 0 1 2 3 4 5 up to 128, and it will be 168. I take it little fast, but still I think it's clear to you, just to revise you how we can do the decimal to binary and binary to decimal conversion. Comfortable up to this? Please do more practice for it. It will be very helpful for you in the upcoming slides to understand about the subnetting, even the structure of IP, even the class of IP. It is must for you to learn this thing. That's why I include here in the IP training. Okay. Suppose we have all ones. We have one IP in binary that is all one. What can be the maximum value? 128, 64, 16, 8421, 255 means 8-bit value. 1 octet maximum value can be up to 255. So as I'm repeating, it's a 32-bit and divided into 4 octet. So minimum value can be 0 and maximum can be 1. What does it mean? What can be the minimum IP? All zeros. All zeros in a IP. And what can be the maximum? 1 1 1 1 1 1. All 1 means all 32 1. So what can be the minimum to maximum value? When we convert it into the decimal number system for our easiness, what can be the maximum to minimum value? So our discussing that what can be the minimum and maximum value of IP. So you can see here in decimal number system, the minimum IP can be 0.0.0.0 to 255.255.255.255. So this can be the minimum to maximum IP value. Maximum to minimum. Clear about the structure of IP? 32-bit address divided into 4 octet. Each octet have 8 bit. The minimum value can be 0.000, all zeros, and maximum can be all 1. When we convert this binary number system, I told you it's very important to understand about the decimal and binary number system conversion. So when we convert it into the decimal number system, it becomes 0.0.0.0 to 255.255.255.255. It is the structure, basic structure of IP. So please, if still have any doubt in decimal to binary and binary to decimal number system, please go back and watch the video again and practice that. Okay. Next and most important also about the different class of IP. Class basically has been identified on the first octet of an IP. There are 4 octet. If you remember, there are 4 octet in an IP. Class is always identified on the base of first octet, what is the value of first octet. On the base of that, we define IP class. So in last video, last PPT presentation, perhaps you remember, minimum to maximum value can be 0 to 0.0.0.0.0 to 255.255.255.255. And if we discuss about the class, this first octet of any IP, identify the class. We don't care about all three octet. Class is always identified based on the first octet. Let's come to the classes. If first octet of an IP start with 0 to 120, 1 to 126. If any IP first octet start with 1 to 126, that is the A class IP. If any of the first octet starting with 128 to 191 comes under the B class. If any IP starting with 192 to 223, C class. Any IP starting with 224 to 239 is a D class. Any IP between first octet 240 to 255 is the E class. Always keep it in mind. By looking at the first octet, you can identify with which class, either A class, B class, C class, D class or E class, this IP belong. What we have seen, that is a decimal format. So make us confused. Let's come back here. Why it end with 126? It can be 125 or 130. Easy to remember. It can be 230 or 225. It can be 190. Why it stop at 192? Why at up to 224 to 239? It is little difficult to remember. But actual reason behind this is again something different. That is the decimal number format that we are discussing. The Y class A end at 126. It can be 125 or 30. Why B class end at 191? It can be 90. Easy to remember. Why C class end at 224? It can be either 20 or 25. Because this is a decimal number system. Actual reason behind this is IP class has been designed in binary, not in decimal number system. See, if I show you any IP in binary number system, if I show you any IP in binary number system and I ask you with which class this IP belong, so by looking at the first octet you can identify. If first bit of first octet is 0, you can say it's a A class. If first 2 bit on any IP in binary number system is 10, it's a B class. And C class IP series always start with 110. You can practice it, you can check it. Any number you convert to the binary between 1 to 126 always end with 0. Any number in between, so you can do a lot of practice here. Any number you take and convert it to the binary, it always come with 10. Remain what is the bit, don't care. Any IP in between these two, either take 193, 200, 221 if you take, its first 3 bit will be 110. So by simply looking at the first octet bits, you can identify, rather than converting into the decimal, by looking at the first octet, you can identify, yeah, it's a class, it's a B class, or it's a C class. Got the reason? What is my purpose to discuss all these things? To make you very much familiar with the binary number system also. So clear up to this? When we are checking about the class, so A class ended 126 and B class start with 128. Please keep your copy and pen ready. Keep your copy and pen ready and check. 127 is not there. What is the use of that? Where the IP 127 series go? What is the use of that? 127 is used for self test of machine and also known as loop back IP. What is the loop back IP? To check whether my NIC LAN card is able to communicate with your operating system, driver is properly not installed or installed properly. So we use for that. That is a different topic. We will discuss somewhere else. So 127 is known as the loopback IP series. So when we talk about an IP, like I'm taking one IP here, so say 192.168.1.10. Okay, leave it 192.168.10.10. Take any IP, for example. Like, how can I identify which portion of an IP is the host part? It is a complete network, and this is the host identification on a network. 100 machine network, like a city, and then house numbers. It is the how you identify it is a complete network, and it is a device inside the network. How to identify? So whenever we take an IP, out of 32 bit, some bit identify a particular network, like a city or a state name or a country name. Same like any telephone number, like yeah, I'll start with it all right, +91 any number. So this particular identify the and read some question about ISP or telephone service provider, and some particular number identify a particular mobile set. In the same way, an IP, some portion identify a particular network, and some portion of the bits identify a particular device. So how we identify that? Which portion of IP belongs to network portion and which portion belongs to host part? So each consists of two parts. Some bits of an IP are network bits and some are host bits. How we identify that? Then we can identify the help of subnet mask. If you have seen the structure there, I've shown you. First is the address, and next is the subnet mask. So how we can identify? These are the default subnet mask for each class. One thing I want to more add here, perhaps some. Let me check. So these are the default subnet mask for A class. Default subnet mask 255.0.0.0. B class first 2 octet belong to 255 means 111. If you convert it into the binary, I'm again and again seeing everything 1 or 0 means binary number. So is it 255 and converted into binary, it will be 11 8 times. So In a subnet mask, one portion represents the network. First is network portion, meaning all are the hosts. First 2 octet is the network portion, that remains the host part. In C class, default subnet mask is 255.255.255. First 3 octet represents network portion, and last octet is the single decimal term, but if you convert it to the binary, here will be 8 represent portion. Let's see some examples. So clearly I told you, by looking at the first octet here, you can define class. Which class is this? It is the C class ID. First 3 digit is 110. Please watch each and every slide carefully. I will show you. If first octet for it is 0, that's the class. If first 2 is 10, then class. If first 3 octet is 110, it is the C class. So it is a C class IP. So as I shown you in previous slide, C class default subnet mask is 255.255.255.0, means all ones. So it will be default subnet mask. So now I think you understand the importance of binary and IP addresses. Default here right now. I should actually also come here. If I configure the IP manually here, change the setting, properties, and if I configure stack here. Suppose 1 to 126 is the A class IP. So say .0.0 and I talk about the host, and then click on the subnet mask. If I click A class, what subnet mask that is 255.0.0 that I was showing you here. A class default mask is this one. So if I come here and click the subnet mask, automatically 255.0.0. For B class comes 191. So we take 190. IP and then click on the subnet mask. Look, it's taking B class default subnet mask. If I take here C class IP means 192.23. Host position. Each machine for each class will be same. Okay, C class automatically this C class default subnet mask. Oh, clear? So this is the subnet mask. So by looking at the subnet mask and when compare it with the IP, the first 3 octet, and this is the host bit. To identify it in a network. This is one network, and this is the host. It will remain same in same network. This host will remain same in same network, and this always varies for one device to another device. It will be changed. So one device giving 100, next device would 132, then next 3, as device we have different host rates. And always subnet mask is always contiguous, can never be contiguous. What does it mean? Like here, it is like this 110001010. Subnet mask never be like that. If network host is same, it is contiguous. It can be like 10 here, 10 here. It can never be possible. So mask is always contiguous. Keep in mind, it can never be discontinuous. Okay. So if we take example of C class, let's try to understand it better. I think this is 92 plus C class started 192. What is it? 1. Advanced mask is this one. So I will share. So now carefully. First IP is known as network IP. Then it is the subnet mask. I got a little bit subnetting. Then we change it. Subnet mask. Then what? First valid IP. The IP that we can assign to the devices. So it keeps changing. It will not change the same network. 92.168.1 will remain same. It keeps changing. 2, 3, 4, 5, 6, 7, 8, 9, and go to 254. It is known as last valid IP. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. You single bit is of that is also valid IP. A single bit is on that is valid also. But when all host bit is off, that is the network ID, and when all bit is on, that is the broadcast ID. I think now it's clear to you. Let's see, we have the E class example also. The network ID, default subnet mask, First valid IP will be 10.0.0.1. Last valid IP will be, write me in the comment, what will be the last valid IP?